Hello, in this video tutorial I'm going to look at avro IDL interface description language. In the last tutorial we looked at how to write to avro and read from avro via Spark job running in local mode, and also we use something called a generic record type. So a generic record is like a name value pairs. You can basically add any name value pairs and then you create a pair RDD, Java pair RDD, and then use save as new Hadoop API file or whatever, and that writes it to a HDFS in avro file format. So there's an alternative way. So in this case what you need to do is there are a number of steps that we need to follow. So firstly we need to define the interface description language, a file called avdl, avro description language. So here if you already don't have source main resources path, if you don't have it, you select your simple Spark, right click on it, then you say new source folder, and then there you'll be typing source src /main/resources. So you'll get this folder. So it's called a source folder because it'll be in the class path. Then you click on it and create a subfolder called avro. So you can create that by right click on it and new, and then you create something called folder and type avro. Inside that I've created a file called order.avdl, avro description language. So firstly you type at namespace, which is com.mytutorial. You can put basically any namespace you want. Then you always have to have a protocol order, open curly bracket and close curly bracket. So protocol is a keyword, and this one you can call it anything you want, your domain, order or whatever. Then inside that you can have multiple records. This is called order, there could be another record called line items, there could be another record called something else, and so on. So in this case I'm going to have order, and we have the same order ID and order name as we specified before. We know that we already have order ID and order name, and in this case it's called the type is integer. So order ID is 1 2 3 4 5 6 etc. If order name, in this case just to demonstrate how do you do optional elements, in this case optional elements I'm saying union, it could be either null or a string value. So that means order name can be null, and its type, if it is not null, it has to be of type string. So order underscore name, and this is the interface definition language. Then what do you do? In the pom.xml file there is a Maven plugin that will read this interface definition language and generate Java objects. So that plugin will be inside the build plugins, and that plugin is called avro Maven plugin, and this is the version number, and then here is saying it's reading the IDL protocol, and that phase it will be running is called a generate sources phase, and this what files to include, where to find the avro files. So it's saying here it will be it's called the order.avdl. So that's the name of the file that we created, order.avdl. avdl is the file extension, and then the source directory we are saying is under source main resources avro, and then the target directory is where the generated Java class files will be stored, which is under target, and under target there's another subfolder called generated sources because these files are generated, and there's a subfolder called avro. So then what happens is, now if I select this simple Spark, right click on it, then do run as, and then I say Maven generate sources. You can also run this phase from outside, from a terminal window. You go to that folder, this folder path here, you can do Maven mvn generate sources, which will be equivalent, it will generating the sources as well. So these source files will be generated inside the target folder. So here what I'm going to do is I'm going to remove this build path, remove from build path, which is we have already done that. So inside the target, now the build has success. Sorry, generate source is successful. See, you can see under generate target, generate sources. You see avro subfolder. That's what we specified in the Maven POM. You can see com my tutorial. So com my tutorial is what this path is, com.mytutorial. So com my tutorial. Then order is the protocol and order type. Okay, and it's called order here. See, order type is basically, it used to be called order type, so I changed the name to order, so it hasn't generated. So what I have to do is right click, run as Maven clean, so it will clean everything. So yeah, the generated classes are gone, and then I can generate again, because it used to be called order type, then I renamed that to order. So you can basically call order type, besides basically record types, order type, line item type, and so on, or you can call it order and so on. So I'm going to right click on it and run as Maven generate sources. So it's going to generate the Java classes. So this target folder is empty because I did Maven clean. So it cleans the target folder and then it's going to regenerate them. So now if I right click, now you can see target folder filled, generated sources, avro, com, my tutorial. So you can see now order.java. So inside that it has created protocol pass, and it has created, so it should really create the order type as well. So what I need to do is I need to go in here and change this to order type. I don't think I can have the same name for both. Order type is a better name anyway, so that's how it should be. Then I go in again, run as Maven clean. I'm going to generate the classes again, so run as Maven generate sources. So this is basically a warning, so don't worry about the execution warning. So there is a way to remove this warning. I'll look at that later. So now it has regenerated it. So now if I go and refresh this again, so now we should have order protocol and order type. So if you don't clean it and run it again, sometimes it won't regenerate. So you got the protocol here and you got the order type. So this order type is in the package com.mytutorial, and order type will have, you can do order type.get schema, it will get you the schema back. So there's a method called, if I do control O and if I do get schema, okay, it's not in the order type, it's in the parent class, it's in the one of the, so it basically extends something called specific record base. So specific record base should have get schema method, and in this case you have order ID and the order name. So order ID and order name are the two fields that it read from the avdl file. So once you have this out of the way, so you have this generated, now we need to add this to the class path. If it is in the target, I won't be able to use it in my Spark code. So the way to do that is go up to avro and we need to add this to the source path. So you right click on it, you click on the build path and then use as source folder. Then you will see it has moved up here, and you will see inside the avro you have that package com.mytutorial, and inside that you have order and the order type. So now what I need to do is I need to go into this new Spark avdl file I created. So here write as avro to hdfs using avdl. So before we were using generic record, now we are going to use this order type as the class. So predominantly the code will be same, only small part is different. So Spark conf is same, local. We are creating a serializer, we are using a cryo serializer here, creating a Java Spark context. Here is what is different. So you're passing the same 1 to 3 John 4 5 6 and so on, but here you're doing create avro specific record base. We're not creating a generic record, but we are creating an avro specific record base. If I press Control and I have to do Control and press the open implementation here. So here I've taken the get schema method altogether out, because as I said, I don't need a get schema like we used to do it here, because for the generic record I need to provide what the schema is, but for this order type, the specific record base, so all these new order type and all those classes that we are generating, so if I go open implementation, extends a specific class called specific record base, and the specific record base will have methods like get schema and so on. So this is from the library class. Here it is. So get, put, internally it's you doing that. Here it is, get schema. So, and the get schema, whichever this implementation is, will have the get schema and it'll return you the schema for you. So that's what we are using here. Order type, OT is equal to new order type. So that's the type we generated. Order type dot set order ID is the order ID that we pass. Or OT dot set order name is order name we pass, and we are sending an order type object which is of type specific record base. So once we get this, we got the order type. We are creating a Java RDD by parallelizing it, the list, coalesce to get one partition. And then we are creating a Java pair RDD, same as the last time. The only difference being, before we said avro key of generic record, in this case is a avro key of order type. So this one is avro key of generic record, see a generic record, and this one is order type, and then the value is null or void. Only the key we are passing away tuple 2, we get avro key of order type, and the value is null. And this is same as we saw before, so we can connect to HDFS. This is the path where I'm going to write it to, so I'm going to write it to the same path, so I should delete the orders before I can write it again. And setting the avro job key schema. See here I'm doing output order type dot get class schema. So when I do order type dot get class schema, it will automatically get you the schemas, but the last time we had to create our own schema in the JSON format like here. So if I click on this method open implementation get class schema, I will see where it is implemented. So okay, it's in the order type itself. So it's my bad, I said get schema, that was an abstract method. So it's in the order type itself. We got a method called get class schema that will get you the schema. So once you got that, you got the pair RDD as I said, and use the coalesce to create one partition, save as new Hadoop API file. You need to pass what format type is avro key, value is null because we are passing void here, and then output format is avro key output format class, and then from this job which we have said, we are setting getting the configuration. Now if I run this again, we should get the same results as before. The orders will be written in avro format. So before I can rerun it again, I have to go into here, go into the orders, and I need to delete this. So I click on the orders here, and I'm going to move to trash, press yes, then I'm going to go into here, then click run as Java application. So this should run and produce the same results as before, but in this case we used avro ideal interface description language, so which is very handy when you're writing large avro files. It's good to have a description language, so somebody can have a look at the description language and generate schema and your Java objects automatically through code generation, and then use those generated classes in your code. So we generated something called order type, and I'm using this order type in my Spark job. So the job is run, no errors here. So I go back to hue. So we deleted it, so I just refresh this. There we go, we got the orders. I click on the orders. You can see this is a success. There's a part file being created. Only one part file is created because I'm coalescing to one. And if I click on this, it'll look very similar to the previous results. So we got the order ID 123, order name John, 456 Peter, 789 Samuel. And as I mentioned before, this is just a rendered version of it, but the actual file will be in a binary format, something like that. Is in a more efficient compressed binary file format. So that's all for this tutorial. In the next tutorial we will cover a couple of things. One is using the avro tools to read the file from a command line, and also we will create a Hive table over this data that we have written, so that we can from Hive we can say select star from a table, and then it will run the MapReduce job to go to this particular orders file and retrieve the data via MapReduce or a Spark job from Hive, and then we can read the data via Hive. So it'll be something like that. It'll be just to give you a preview. So it'll be, if I go to my Hue editor Hive, if I do select star from here, because I have already created this here, so you can see they create external table stored in format, and then table properties, you point to your schema where it's sitting, and location. See, this is where my orders data is, user Cloudera avro orders. That's that path here. So once you create this table, and then you do select star from order, and then you'll get the results like this in a tabular format. So this is handy for a data scientist. So once the programmers have written a Spark job that periodically, so you can schedule your Spark job that runs every day or every hour or every minute or whatever, depending on how often you get the data, and you can run it on a yarn cluster, and you can use Uzi workflow to schedule your jobs, and then it periodically runs every hour, minute or whatever, and then it'll write your files into avro format, and then you would have already created this table as well. Then data analysts come and do their select queries with where clause and so on to retrieve the data. See here, you get the order ID and order name 123 John, 456 Peter, 789 Samuel. So we'll look at this in detail, and also the avro tools in the next tutorial.